All right, guys, today I'm going to walk you through a few of the problems on this balancing and classifying chemical reactions worksheet. I'm going to start with the balancing and then I'm going to do the classifying after that. So this first reaction is actually one of the kind of more difficult ones simply because it's got oxygen in 3 different species in this reaction. But our goal in balancing is on either side of the arrow to have the same number of atoms of each element. So on the left side, we've got 1 carbon. On the right side, we've got 1 carbon. On the left side, we've got 4 hydrogens. On the right side, we've only got 2 hydrogens. So we put a 2 right there, and that 2 doubles everything in the water. So it gives us 4 hydrogens and 2 oxygens. So if we count our oxygens, on the left side we've got 2 oxygens. On the right side we've got 2 oxygens and CO2 plus 2 oxygens from the water. So 2 plus 2 is 4. So over here we've got 2. If we put a 2 out in front, that gives us a total of 4. And if we look at the second problem, the sodiums are the same, but on the left side we've got 2 iodines, on the right side we've only got 1. So if we put a 2 out in front, that gives us 2 iodines, but it also gives us 2 sodiums, so we need to go back over here and put a 2. What you are not allowed to do is just try to balance it by sticking a 2 down there, because if you remember from several months ago now, sodium has a +1 charge and iodine has a -1 charge. So the formula is just NaI. You can't just start making stuff up. I'm going to skip down a few to get to some of the ones that gave people the most trouble. Number 5. This is one of these where we have a hydrogen and then we have a hydroxide, and then on the other side we end up with water. And this is one of those cases where it's probably easier to write water as hydrogen hydroxide, so we can help keep track of things. So if we look right now, we've got 1 hydrogen, we've got 2 chlorines. So let's put a 2 out in there for in front of the HCl to balance our chlorines. We've got 1 calcium on each side. We've got 2 hydroxides and 2 hydrogens. We've only got 1 HOH. So if we put a 2 right there, that gives us 2 hydrogens, 2 hydrogens, 2 hydroxides, 2 hydroxides. And it's nice and balanced. Skipping down a few more. Look at number 10. You may notice that we have a potassium on each side. We got 1 iodine here, 2 iodines there, so we put a 2 out there. That also changes our potassium, so we need to put a 2 right there. We've got a lead on each side, and we have 2 nitrates and 2 nitrates. So it's all nice and balanced. Number 12 may have given you a little bit of trouble. If you look at this, we've got 2 hydrogens on each side. We've got 2 oxygens here, and then we've got 1 plus 2. So we've got 3 here and 2 there. So it's a little bit tricky, perhaps, to figure out how to get everything nice and even. Because, if this were like a 1/2, that would balance things out, where half of 2 oxygens is 1 plus 1 is 2. But we can't use fractions to balance this. We need whole numbers of things. So if instead we just double everything, that gives us a 2, and a 1. And typically we don't actually write the ones, you just leave it blank. Number 13 is one of those where you've got water on one side and then you have hydrogen and hydroxide on the other. So if you rewrite water as hydrogen hydroxide, it might help you see what's happening, because we've got a sodium on each side, we have a hydroxide on each side, but we have 2 hydrogens here and 1 there. So we need to put a 2 there. That also gives us 2 hydroxides, so we need to put a 2 here to equal the hydroxides. That also gives us 2 sodiums, so we need to go back and put a 2 out in front of the sodium. Number 14, I think gave people more trouble than just about any other problem on here. Because if you start balancing it, you've got 2 carbons on the left, you've got 1 on the right, so you put a 2 right there. You've got 6 hydrogens there, 2 on the right, so you put a 3 right there because 3 times 2 is 6. Then we count out the oxygens. We've got 2 on the left, and then we've got 2 times 2, which is 4, plus 3, which is 7. So what times 2 is 7? Well, that's 7 halves. That's no good. We can't have a fraction there. So we're just going to need to double everything in here. So if we double that, that gives us a 2 there. 7 halves times 2 is 7. This becomes a 4, and this becomes a 6. This is also why it's better to do these in pencil than in pen. But that's a whole different matter. Let's see. How many more of these do I want to try? If we look at number 15, we've got 1 magnesium on the left and 3 on the right. So we put a 3 right there. That gives us 3 times 2, or 6 nitrates. And over here, we've only got 1. So put a 6. 3 potassiums, 6 potassiums. So we put a 2. And then that gives us 2 phosphates, 2 phosphates. We're done. All right, so that's really, let me do one more and then move on. Last one I want to show you is number 17, as you have 1 aluminum here and 2 aluminums there. So you put a 2 right there. Then we have 2 oxygens on the left, 3 on the right. Well, the only way to get those oxygens equal is if they all add up to some multiple of both 2 and 3, and the least common multiple between 2 and 3 is 6. So we need our oxygens to equal 6. So that means we're going to have to put a 2 on this side and a 3 on that side. Now that also changes our aluminums. We now have 4 aluminums over here, so we put a 4 there. Then, when it comes to classifying reactions, I'll address that in just a minute. For classifying reactions, it's really helpful to look on page 6 of your reference tables, where it has this thing as guidelines for predicting the products of selected chemical reactions. And then it gives you the general formats of each of these. And the easiest one to overlook if you're not paying attention is combustion. So even though it's written last, I would look for the combustion reactions first, because they always have something with hydrogen and carbon in it, plus oxygen, and it makes carbon dioxide and water. And right off, the first one on here is a combustion. Let's see, this one adds oxygen, but there's no hydrocarbon in there. That one has oxygen, no hydrocarbon. Number 14 is a combustion. And then the only other combustion one on here, I think, is number 20, is also combustion. So then we're looking at synthesis reactions. The key to synthesis reactions is that you have 2 reactants and only 1 product. So 2 different things on the left side, 1 on the right. So something plus something making 1 thing. So number 2 is synthesis. Number 3 is synthesis. Number 6 is a synthesis. Number 9 is a synthesis. You're taking 2 things, you're adding them together, and you're making 1 thing. Number 17, even though we have 2 aluminum oxides, that's just 1 product, 2 reactants. So number 17 is also synthesis. Decomposition is the exact opposite. You take 1 thing and you break it apart. So you have 1 reactant, multiple products. So number 7 is decomposition. To decompose just means to break down, like when dead plant or animal matter decomposes, as you learned in biology, it breaks down. Same word means the same thing. Number 18 is also a decomposition. I still haven't gone through and balanced it, but it's decomposition nonetheless. Single replacement. The key to single replacement is you have one thing that's by itself on each side of the arrow. So like in number 4, we have chlorine is by itself on this side, iodine is by itself on that side, so that is a single replacement. And we move down and look for some others. Number 13, we have sodium is by itself on the left side, and hydrogen's by itself on the right side. So that's also single replacement. Then the last type we haven't talked about is double replacement. That's where everything just changes places. And that's going to have to be pretty much any other type of reaction we've got left has to be double replacement as the only other option. So for instance, number 5, that's a double replacement. The hydrogen was with the chlorine and the calcium was with the hydroxide, and now the calcium is with the chlorine and the hydrogen's with the hydroxide. So everything switched places. Number 8 is also a double replacement. You had potassium with phosphate, hydrogen with chlorine, and now we've got potassium with chlorine and hydrogen with phosphate. Hopefully that helps. I didn't go through every one of these because I want to leave some for you to try on your own. If you still run into issues, just send me an email, let me know. I'll see if I can help you out with it.